Okay, here's number 1 from the targeted review on linear modeling. The temperature outside is rising at a steady rate of 3 degrees Fahrenheit every hour. If the temperature starts at 32 degrees, do the following. So we're going to fill out a table, write an equation, and then do some work with that equation. This first part where we're filling out the table, all we need to do is put in our degrees. So we're starting at 32 degrees, and our temperature is rising 3 degrees every hour. So then we're going to have 35 degrees, plus 3 again, 38 degrees, plus 3 again would be 41 degrees. Now, we want to write a linear equation. So our equations look like this. This is the only kind of equation we know how to write yet. We will learn another kind before the end of the semester. So in this, our last blank is our start, and for this problem, it's going to be our starting temperature. Our first blank is always our rate, and the word that we're looking for there is per most of the time. So our starting amount we can get from our table, or we can get from our description. Our starting amount was 32 degrees, and it was a positive 32. And our rate, it doesn't say per in our problem, but it says 3 degrees every hour. So we could write that as 3 degrees per hour. So that's going to go in front. It is a positive 3 degrees because we are going up 3 degrees every hour. That's something you want to be really careful with. Now I'm going to switch now to F and T. So time is always going to replace X. So I'm going to do 3T plus 32. And that means our Fahrenheit, F, is going to replace Y. And using those variables is really nice. Now when we switch over to Desmos to do the rest of our work here, we're going to have to put in the X and Y equation. The F and T equation is what the OST might ask you for, or it's what you might want to use practically because it's a little easier to plug into when you know what those variables are. All right, I'm going to pull up Desmos, and we're going to put that equation in. So our equation was y equals 3x plus 32. And again, we don't see, you got to zoom out a little bit. And our table is generally what is the most helpful here. So the first thing we're asked is, according to our equation, what's the temperature at T equals 2.25 hours. So T is our X. You can absolutely put that into the equation, or you can put that into Desmos. So it would be 38.75. If this was a test problem, I would want to see this. Or I would want to see you plugging that into the equation. So there's one of the ways that you could answer this. The other way that you could answer this is this. And then do that calculation. So 2 ways to do that problem, however you like it. If the heating continues, when will the temperature be 65 degrees? Sorry, it doesn't make any sense that it says freezing there. Our temperature is rising, so when are we going to be at 65 degrees? So you can with Desmos, you can scroll along this line a little bit, if you can click on there close enough. We can put in values for our x's and see if we can get close, or you can solve the equation. I think what you guys have been liking to do the most is kind of guess and test with Desmos, and I love that. So I'm going to put 10 hours in and see where we are. At 10 hours, we're at 62. We want 65. So I'm going to go 11, and there's 65. You could go up by 1s, you can go up by 5s until you get close, whatever works for you. Again, if you're using Desmos for this, the work that I would want to see is just what's in your XY table. So I'd probably put in 10 and 62, and 11 and 65. And then I want to see see that interpretation, 11 hours. Interpret the y-intercept in context. This is something that's already in the problem. We're just restating. The temperature started at 32 degrees. Interpret the slope. So we did that a little bit. We have 3 degrees per 1 hour. The temperature is rising because it's positive at a rate of 3 degrees per hour. And state the practical domain. So domain, remember, is just our x values. And practical domain means that what makes sense for this problem. In this problem, we're not going to go back in time. So we're going to say x is greater than or equal to 0, or you can say t is greater than or equal to 0. That's number 1. If you have additional questions on this problem, please let Mrs. Margraf or myself know. You are going to see questions like this on your test, on the practice test, and on the test. So we want to make sure the review is as helpful to you as possible.